In this video, we're going to take a look at calculating molarity and calculating molality. Molarity and molality are both measures of concentration. Molarity, mathematically defined, is moles per liter. So let's get a color here. Let's start out with a red. So, mathematically speaking, molarity is a capital M. If you see a capital M, that stands for molarity. So, molarity is equal to moles of solute, and solute is the substance that is getting dissolved or being dissolved. So, molarity is moles of solute divided by liters of solution. So one thing to keep in mind whenever you are calculating molarity, your units in the numerator on this particular part of the equation must be in moles because you're looking for moles, so don't make a mistake and put grams up here because moles go, not grams. So if you look in the bottom, the unit that we need here is liters. Sometimes when you look at a problem, it will give you the volume in milliliters, so don't forget to convert it to liters. Now, molality is abbreviated with a lowercase m, and molality, the formula for molality is moles of solute. So we've got the same quantity, or the same thing in the numerator. The only thing that changes is the denominator, and the denominator for molality is kilograms. So kilograms of solvent. So I'll put kilograms of solvent. Now the reason we have to make a distinction between molarity and molality is you'll see later on when we do some colligative properties and we're changing the temperature of our solution, that if you change the temperature of a solution, the volume of that solution actually changes. So if we're using molarity and volume is in the bottom, in the denominator, we're using liters, and we are changing the temperature and our volume changes, well, this is going to change our molarity. So basically our concentration of our solution is going to change based upon the temperature if we're using molarity. But now if we're using molality, it doesn't matter the temperature of the solution. The kilograms, the actual mass of solvent that you have, is not going to change. So the molality will not change based upon temperature, whereas molarity can change based upon temperature of a solution. Okay, so now that we've mathematically defined what molarity and molality are, let's do a couple of problems. So this first problem says, what is the molarity of a solution that contains 55 grams of copper 2 chloride, and this should be dissolved, D-I, and not dissolved, but dissolved in 1500 milliliters of water. So the first thing to do is to write out our formula. So we said that molarity, capital M, molarity is equal to moles of solute, but I'm just going to put mole divided by liters. So liters is solution. So moles divided by liters. So they give me 55 grams of copper 2 chloride. So I have grams. I need to convert my grams into moles. So if I've got copper 2 chloride, remember this is a review. So this 2 in Roman numeral tells me my charge on copper is a positive 2, and the charge on chlorine is a negative 1. These numbers do not cancel out like they are, so I must switch them. So copper chloride is a CuCl2. This is what copper 2 chloride is if we were to write it out in its chemical formula. So let's set up a ratio. So we're going to say 55 grams of CuCl2, and we want to find out how many moles that is. So I'm going to say X moles. So we're going to go over here to the right. Because I've got grams of CuCl2 on the top, I'm going to keep grams of CuCl2 in the top here. And in the bottom, I'm going to put over 1 mole. So I need to calculate the molar mass of copper chloride. And the molar mass of copper chloride that we're actually going to use is 134.446 grams. 446 grams. Sorry I couldn't fit that in, but I was running out of room. But anyhow, if you add up the mass of copper and add the mass of 2 chlorine atoms, you will get 134.46 grams. So this is the molar mass of copper chloride. So here, if I cross multiply, I take my x times my 134.446. So then I get something that looks like 134.446 x. And then if I cross multiply my 1 times my 55, I'll get 55 here. So in this case, I divide this side by 134.446. There's my decimal. And divide this side by the same, 134.446. Sorry, you can't see that decimal. Alright, so now, so I'll scroll down just a little bit so we can get our x. So, x is going to be, once I divide my 55 by the 134, I get x to be 0.4091, and the units on this number is the x was with the moles, so we're going to say moles of CuCl2. So I'm going to take this number now, this is my moles, and I'm going to place it into my formula for molarity. So molarity was equal to moles, so we calculated our moles to be 0.4091 moles. And our liters from the problem, if we can scroll back up to the problem, it says 1500 milliliters. So we have to use liters. This says milliliters. So to convert milliliters to liters, I'm just going to take the decimal, which is understood to be behind this last zero, and I'm going to move it 1, 2, 3 places to the left. So I'm going to get 1.5 liters. So 1500 milliliters is equal to 1.5 liters. So that's what I'm going to put in the denominator here, 1.5 liters. So when I take 0.4091 and divide by 1.5, I'm going to get a molarity of 0.273 molar. So for molar, you can either write out the word molar, or you can just write a capital M. I know this kind of seems redundant right here because I've got a capital M on the left and then I've got a capital M on the right, but this is technically the unit, so you can either write the word out molar or you can put a capital M. Either one of those will be sufficient. So now let's scroll down and let's do a different type of problem. In this problem, they're asking for us to solve for molality. Okay, so let's just to change it up, let's just grab a different color. Okay, so our formula for molality is molality is equal to moles divided by kilograms. Okay, so I've just kind of simplified this from what I showed you in the beginning of the video, but basically this is what you're doing. So what is the molality of a solution that contains 45 grams of NaCl? So once again, they give me grams, which always makes another step because I have to convert the grams into moles, but it's no big deal. So let's just go ahead and set up a ratio. So we've got 45 grams of NaCl, and I want to know how many moles that is. So I'm going to say X moles of NaCl. So now the other side of my proportion, I'm going to add the mass of sodium to the mass of chlorine, and that's going to give me a molar mass of sodium chloride to be 58.44 grams, and this is NaCl. And I know that that is 1 mole. So that is the molar mass. So 1 mole of NaCl. That is 1 mole of NaCl. So now I just cross multiply and divide. And by this point in the game, you can probably do this. So I won't actually write out the work here. I'll just write what my x is for moles. So after you cross multiply and divide, you're going to get 0.77 moles of NaCl. So we've got 0.77 moles of sodium chloride. So now we're going to take this number, because we've got our moles, and we're going to plug it into the top of this equation. So molality is equal to moles, so I'm just going to write this number, 0.77 moles. And kilograms. So we go here, it says 600 grams of water. Well, once again, the units they give me are in grams. I need kilograms, so in order to convert the grams to kilograms, I will move the decimal that's understood to be behind this last 0 3 places to the left. So I'll say 1, 2, 3. So that's going to give me 0.6. I always kind of like to put a 0 in front of my decimal. It just kind of helps me to keep things straight and just know that this is an actual decimal, not just some stray mark. But anyhow, it is zero point 0.6 liters. Zero point 0.6 liters is equal, or no, not liters. 0.6 kilograms. So zero point 0.6 kilograms is equal to 600 grams. So let's put the or 0.6 kilograms in the bottom. And then once you take 0.77 and divide by your 0.6, let's see, what do you get here? If I get my calculator, so we'll say 0.77 divided by 0.6, and my molality I get to be 1.28. So 1.28. So I'll darken up my decimal here. So 1.28. So the units on this, I can either say molal. That's kind of a funny word to say, but that's it. It's molal. Or I can put a lowercase m. Both of these mean the same thing, so you don't have to put both of them. You can put either or. But anyhow, this would be the unit, the unit on the 1.8. So the answer to this question is 1.28 molal for this particular saltwater solution.